हेलो स्टूडेंट्स। मैं हूं डॉक्टर प्रीति एंड आज आपकी ही डिमांड पे वी आर गोइंग टू स्टार्ट विद द रिवीजन ऑफ कार्बन एंड इट्स कंपाउंड्स. Carbon and its compound has a total weightage of 7 marks in your board exams, out of which 2 questions will be coming for 2 marks each. One question will be an MCQ and 2 questions again will be 1 marks question, but they will be very short answer type questions in which you have to answer in one line or one word. Okay. In carbon and its compound, it's a very interesting chapter, and in carbon's compound the most important topics is about functional groups. Functional groups could be like alkanes, alkenes, alkynes. Then we have alcohol group, aldehyde group. So all that we will be considering today. But we will start with some basics of the chapter, carbon and its compound. So what type of bonding occurs in carbon and its compounds? That is a covalent bond. The bond that is formed in carbon compounds are covalent bonds. What are covalent bonds? The bonds that are formed by sharing of electrons. For example, if we consider example of carbon only, that carbon has atomic number 6. Its outermost shell has 4 electrons. Now you know that every element tries to attain the octet, tries to complete its octet. So for completing the octet, it requires to either gain 4 electrons so that it can have a configuration similar to that of neon, so that it has a complete octet, or it can try to lose 4 electrons so that it can have a configuration like noble gas helium. Every element tries to have a noble gas configuration. But gaining 4 electrons and losing 4 electrons is not practically possible. If an element tries to gain 4 electrons, then a lot of energy is required to gain the electrons. A lot of when one electron is gained, the repulsion between the electrons in the outermost shell increases so much. And in the nucleus, there are only 6 protons. है ना? Carbon has atomic number 6, so number of protons is also equal to 6. So if it tries to gain 4 electrons, then handling 10 electrons, 6 of its own and 4 from someone else. To complete the octet, it requires 4. So handling 10 electrons by an atom having just 6 protons, that is not possible. है ना? Such a lot of negative charge cannot be handled by just plus 6 charge. So that is not possible for carbon. Apart from that, it cannot even lose 4 electrons because losing electrons require a lot of energy. The element has to be provided with energy so that its electrons could be removed. So gaining 4 electrons or losing 4 electrons is not possible for carbon. Then how it forms the bonds? It forms the bonds by sharing of electrons. It shares the electrons with some other elements and then that bond is formed. Such a bond is known as covalent bond. Bonds formed by sharing of electrons. Fine. So carbon, for example, if we take the example of methane, CH4. In CH4, that is methane, carbon forms bonds with hydrogen. So here is carbon having 4 electrons in the outermost shell, and we have hydrogen also. Hydrogen has just 1 electron in the outermost shell. So what hydrogen and carbon do, that carbon forms bonds with 4 hydrogen atoms sharing 1 electron with each of the hydrogen. So that hydrogen wants to attain the helium gas configuration, nearest noble gas, and carbon wants to attain the configuration of neon, that is the nearest noble gas to carbon. So both of them just tries to attain those configuration by sharing of electrons. That is how a bond is formed between carbon and hydrogen. Similarly, not only carbon, other elements also shows covalent bonds. Covalent bond is shown by other elements also during the formation of their molecule. For example, we'll see some covalent bonds and then we will move to once again to carbon. The compounds of carbon are very, very important. In your higher classes, you will be reading an entire section of chemistry known as organic chemistry based on just carbon and its compounds. So it's a very, very important chapter for your future also. It's a basics that will be applied in 11th and 12th standard chemistry also. So looking at the other elements that forms covalent bonds, just have a like we'll see hydrogen. Hydrogen is one of the elements that forms bond as in the form of covalent bond. Hydrogen has one electron in the outermost shell. Now if one atom of hydrogen is there and here we have another atom of hydrogen, they both are looking for one electron each. So what they do, this is one electron of this hydrogen, this is one electron of the other hydrogen. What they do with each other? They share that electron and form a single bond. Since one electron is shared, so such a bond is known as a single bond. So, a hydrogen molecule is formed by a single covalent bond. If we look at example of oxygen, then oxygen has atomic number 8 and its electronic configuration is 2 and 6. It has 6 electrons in the outermost shell. To complete its octet, it requires 2 more electrons. So what it can do, this is one oxygen atom, this is another oxygen atom. They can share 2 electrons with each other. Okay. So these are the 2 electrons of this oxygen. I'm just showing it right now. 1, 2, 3, 4, 5, 6. These are the 6 electrons of this oxygen atom. Let's draw the 6 oxygen electrons of that oxygen atom also. 1, 2, 3, 4, 5, 6. 6 electrons of this oxygen atom. So what they do, they both want 2 electrons. So since they want 2 electrons, they are going to share 2 electrons with each other. Okay. Such a bond between 2 oxygen atoms is a double covalent bond. Double covalent bond because there is 2 electron pairs are shared with each other. That is required to complete their octet. Now if I ask you about nitrogen, what do you expect? Will it be having a single covalent bond or a double covalent bond? Just let's have a look. Nitrogen also forms nitrogen molecule by forming covalent bonds. Nitrogen has atomic number 7 and electronic configuration 2, 5. Its outermost shell is having 5 electrons. So to complete its octet, it requires 3 more electrons, which could be managed by sharing 3 electrons. Now you have guessed it correct, I hope. So this is one nitrogen atom. This is another nitrogen atom. They are going to share 3 pairs of electrons like this. So 3 electrons will be showing in the overlapping circles. Whatever electrons are shared, that we always show in overlapping circles. Okay. And how many electrons are left with each of them? 3 are shared, 2 are remaining. Total were 5. So 2 electrons we can show that is not taking part in the bonding. So nitrogen forms triple covalent bond. Between 2 nitrogen atoms, we see a triple covalent bond. Triple covalent is the maximum. There couldn't be a quadruple bond. For example, carbon needs 4 electrons, but 2 carbon atoms cannot form a quadruple bond. Okay, because if they form quadruple bond, if they share 4 electrons with each other, the distance between the 2 atoms will be so less, they will come so close to each other that they will be having a lot of repulsion between them. So that is not at all possible, and the maximum number of bonds that could be formed between 2 atoms is 3. So it's a triple covalent bond. Okay. So these can also come as 1 marks questions for you all, as a skill based question that draw the electron dot structure of nitrogen, oxygen, hydrogen. So you can draw all that. Okay. One last electron dot structure of an element that we are going to see One of the molecules that we are going to see is sulfur. Sulfur has 8 atoms bonded together. Okay, sulfur is placed in the periodic table just below oxygen. So it is also having 6 electrons in the outermost shell. Its atomic number is 16 and it has the electronic configuration 2, 8, 6. So to complete its octet, it requires 2 electrons. But sulfur exists in the form of S8. 8 atoms of sulfur join together to form a ring-like structure and the bonding between them. Okay, so whatever we are dealing in this chapter are very important topics only. We are not dealing with each and every topic of the chapter. We are just dealing with very important topics only. So each and everything what we are discussing now is very very important for you all. So it's 1, 2, 3, 4, 5, 6, 7 and 8. 8 sulfur atoms are there which are in a circle. So in each circle just write S representing sulfur. Between every 2 sulfur atoms we have a single covalent bond because sulfur requires 2 more electrons. So this sulfur will be bonding 1 electron on one right side and one on the left side. So between every 2 sulfur atoms we are going to just show 2 electrons that will represent a single covalent bond. Draw proper circles, preferably using a compass, so that you give very nice, very good diagrams for you. Okay, so this is how sulfur forms a bond, S8 sulfur molecule, and that is a ring shaped structure that is formed by sulfur. That is also a covalent bond that is given as an NCERT question, so that can come in your exams also. So that's why I told you. Now, one of the question that can come in your exam is why carbon forms so many bonds? Why carbon exists in so many forms? Carbon has such a big family that if you just write the name of carbon and its compound on one side and write the name of all the elements put together on the other side, the family of carbon is bigger than all other families put together. So carbon has such a big family. But why? That is asked in the question, that which properties of carbon helps it to make so many compounds. Why carbon forms so many compounds? That can probably come as a 1 marks question. So here you are not expected to write the details if it comes as a 1 marks question. The 2 properties that helps carbon to form so many compounds are, first is catenation. Now, what is catenation? Catenation is forming bond with a similar atom. Carbon can form bond with another carbon atom in the form of straight chain, branching, cyclic chain. We'll see all the three, but carbon can form bond with other carbon atoms. This property of carbon is known as catenation. Second property of carbon that helps carbon to form so many compounds is tetravalency. The valency of carbon is 4. So it has many options. It can form bond with 4 hydrogen atoms. It can form bond with 3 hydrogen and 1 could be chlorine. So that will be another compound. It can form bond with 2 chlorine atoms and on two other valency could be satisfied by hydrogen. So it has many options. So for that reason, carbon forms tetra, carbon forms so many compounds. Probably you will be asked to name the properties due to which carbon forms so many compounds. So that is catenation and tetravalency. Probably according to me, this might come as a 1 marks question, because in 2 marks question, why I'm saying that, because in 2 marks question you will be asked the questions based on application and skill. Skill based questions and application based questions are those where you have to put your knowledge, whatever knowledge you have gained from the chapter, you have to apply that knowledge and answer the question. So for 2 marks question, you don't have any knowledge based question. Knowledge based question is just simply writing whatever is written in the book. Okay, simply writing that as a knowledge based question. So knowledge based questions will come as 1 marks question, and application and understanding based questions will come as 2 marks questions from the chapter. So that is why I'm saying that is this has a probability for coming for 1 marks. In that case, you need not write any details, just name the properties. Okay, fine. Next, 1 marks question that can come from your chapter is to write the names of allotropes of carbon. Allotropes of carbon are graphite, diamond, Buckminster fullerene. Buckminster fullerene, diamond, and graphite. These are the three allotropes of carbon. I hope you know what are allotropes. So these are the three allotropes. Next, 1 marks question from this part of the chapter that can come is, it was believed that earlier it was believed that organic compounds, that is carbon compounds, could be synthesized inside a human body only. They couldn't be prepared in the laboratory. So it was believed, that is why they were known as organic compounds. Organic word means some living organism. So Wohler was the first scientist that could be asked in a question. Name the scientist who first prepared a organic compound in the laboratory and name that compound. Okay, so these are two questions that are probable to come as 1 marks questions. First is name the compound that was first prepared in the laboratory artificially. So that is urea. Urea was the first compound that was prepared in the laboratory, and who prepared that? The name of the scientist is Frederick Wohler. He told how organic compound urea that could be prepared in the laboratory. Okay, why I'm saying that urea is a organic compound? Urea is present in urine also. It is one of the components of urine also. So it's an organic compound formed in the living organisms. But Wohler prepared it. Frederick Wohler prepared it in the laboratory. Okay. Now, the next thing that is most important from this chapter is about saturated and unsaturated carbon compounds. Now we are coming to the most important part of the chapter, from which probably you will be having 2 marks questions. Saturated and unsaturated hydrocarbons, that is one topic. Then forming the bond between the carbon atoms, that it could be the bond between the carbon atoms could be in the form of straight chain, branching, and cyclic chain. So both these topics we are going to see next, very important for exams also. So first we are going to consider about the saturated and unsaturated hydrocarbons. What are hydrocarbons? The compounds containing carbon and hydrogen are known as hydrocarbons. Now, if all the bonds present in a carbon compound, in a hydrocarbon, are single bonds, that is known as a saturated hydrocarbon. For example, these three carbon atoms are bonded together with each other, and rest of their valencies is completed by हाइड्रोजन. रिमेंबर कार्बन हैज अ वैलेंसी ऑफ 4, तो हर एक कार्बन की 4 वैलेंसी कंप्लीट होनी चाहिए. फर्स्ट कार्बन हैज one bond with this carbon, second hydrogen, third and fourth. So its 4 valencies are completed. This one is already bonded with 2 carbon atoms, so it's having a scope of joining with 2 other hydrogen atoms. This one again can bond with 3 other hydrogen atoms. So, if the bond between the carbon atoms are all single bonds, then such a compound is known as a saturated hydrocarbon. One interesting thing is that ghee that we consume at home, that is also a saturated hydrocarbon. And it's one more thing, that ghee, that is saturated hydrocarbons, are unhealthier as compared to oil, that is unsaturated hydrocarbons. Okay, usually it is there at home that when the mother is preparing something, then the mother usually tries to give the best to their kids. And the mother, even if she is preparing something with oil for all the family members including herself, she will be preparing it with ghee for her kids. But actually the thing is that Saturated hydrocarbons is not a healthy option. Oil is healthier as compared to saturated hydrocarbons. And not only oils, all the animal food is saturated hydrocarbon, and all the plant based food, plant based oil, that are unsaturated hydrocarbons. So the fats that we get from the animals could be in the form of milk fats, it could be in the form of meat, that is all saturated fats that are unhealthy as compared to oil or any plant source of fats that we are getting. Okay, so next time onwards, try to consume more oil and restrict on ghee. Okay, now coming to unsaturated hydrocarbon. Unsaturated hydrocarbons are those carbon compounds that are having either a double bond or a triple bond. If between the carbon atoms, so I'm just taking the example in all the three conditions with three carbon atoms. Okay, you can take the example with 2, 3, 4, anything, but I'm just taking the example with three carbon compound. So if there is a double bond or a triple bond between the carbon atoms, such a compound is known as unsaturated hydrocarbon. Okay, remaining valencies will be satisfied by hydrogen. So we are going to attach hydrogen. Two valencies are already done. This is the third one and this is the fourth one. This, it's already bonded with 3. Its 3 valencies are satisfied. 1 satisfied by hydrogen. Now you can place this hydrogen above carbon or below carbon. It doesn't make any difference. It's the same only. Now this carbon will be bonded to 3 more hydrogen atoms to satisfy its valency. Okay. Now here, when there is a triple bond, let's see, 3 valencies are already satisfied. One more here with hydrogen. If we observe this carbon, it's already 1, 2, 3 and 4. 4 valencies are already satisfied. So it will not form any bond with any more hydrogen. This one will form bond with 3 hydrogen atoms. Now, if we write the formula of these 3, we will be able to find out the difference. So it's having the formula C3, 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is 8. If we write the formula of this unsaturated hydrocarbon, this is C3, 1, 2, 3, 4, 5, 6, H6. And here it will be C3 and 1, 2, 3 and 4. 4 hydrogen atoms are there. Okay. So such a hydrocarbon, which is a saturated hydrocarbons have another name and they are also known as alkanes. Alkanes have all the bonds as single bonds. Okay, why they are called saturated? Saturated solution आपने 9th में भी पढ़ा है ना? If you are preparing a sugar solution or salt solution, when you cannot add more sugar to it, more salt to it, then we call that solution is saturated. When something is completely filled with something, then it is known as saturated solution. So why we are calling this compound as saturated? Because it's all the valencies are satisfied by hydrogen. Can we add some more hydrogen to it? No, not possible. All the bonds are already single bond only. तो अब और hydrogen possible नहीं है. That is why we call it as saturated hydrocarbons. So alkanes are saturated hydrocarbons. Then we have some unsaturated hydrocarbons. Unsaturated hydrocarbons में दो categories होती हैं. When the bond between carbon atoms is a double bond, then that is known as alkenes. If the bond between two carbon atoms is a double bond, that is known as, such compounds are known as alkene. And if they exist having a triple bond between them, then it is known as alkynes. Then they are known as alkynes because there is a triple bond. So single bond, alkanes. If a double bond exists, then it is alkenes. And if it is a triple bond that exists between the carbon atoms, that is known as alkynes. In alkenes and alkynes, you can see that with 3 carbon atoms, in alkanes there were 3 carbon atoms were attached to 8 hydrogen atoms. In alkenes and alkynes, you can see that here 3 carbon atoms are attached to 6 only. So if you want to add more hydrogen, two more hydrogen could be added by breaking this bond, by making it a single bond. Here also C3H4 is there. So only 4 hydrogen atoms are there as compared to alkanes having 8 hydrogen atoms. So you can add more hydrogen to it, and that is why such hydrocarbons are known as unsaturated, not totally full with hydrogen. Okay, so that is about alkanes, alkenes and alkynes. Now we are going to write the most important part of that. We are going to write some the homologous series for alkanes, alkenes and alkynes, and we'll see what is a homologous series. So I hope whatever we have studied till now, it's clear to you all. I'm moving quite fast. I know that. We are just revising the topics, expecting that we have all studied these topics. So we are just considering the most important topics, and that too very quickly. So the next that we are going to do is the homologous series of alkanes, alkenes and alkynes. And now we'll see what is a homologous series also. So just let's see about alkanes. Number of carbon atoms that are present in a hydrocarbon that results in the name of that particular hydrocarbon. For example, every hydrocarbon has a root word and a suffix is added to that. Okay, let's see how is the thing. So if a hydrocarbon is having just one carbon atom and that is having all the bonds that are single bonds, so meth word is used for one carbon atom. The root word that is used for a single carbon atom is meth. And if all the bonds are single, just let's draw it. One carbon atom is there and rest every valency will be satisfied by hydrogen. So its formula will be CH4. CH4 is known as methane. It is known as methane. Methane. Why methane? Because its name will be methane because it's an alkane. So for alkanes we use the root word ane, and since it's having single carbon atom, so it's known as methane. Now if it is having two carbon atoms, then what will be called as eth. Eth is the root word used when two carbon atoms are there. So let's draw a hydrocarbon having two carbon atoms, and rest all the valencies will be satisfied by hydrogen. So since two carbon atoms are there, it will be known as eth, and since it's a saturated hydrocarbon having all the single bonds, so it will be known as ethane. That's called ethane. If three carbon atoms are there, similarly, then it will be called as propane. Okay, so remember, if three carbon atoms are there, then the root word will be prop and it will be known as propane. Similarly, you just draw three carbon atoms and remaining valency is satisfied by hydrogen. If four carbon atoms are there, then the root word that we are going to use is butane. Okay. Similarly, if 5 carbon atoms are there, that is known as pentane. If 6, that is known as hexane. If 7, then it's known as heptane. If it's 8, octane, 9, nonane, and 10, decane. Okay. So till pentane, even till hexane, if you remember, that is sufficient for you all. One carbon atom, methane in case of saturated hydrocarbon. Two carbon atoms, ethane. 3 propane, 4 butane, 5 pentane, 6 hexane. Okay, so you need to remember the number of carbon atoms. So if I ask you to write the formula of pentane, so you should be aware that I am saying pentane means how many carbon atoms you have to draw. You have to show 5 carbon atoms. Sometimes in your exam it could be there that you could be given the name of the compound and you will be asked to write the formula. So if I'm telling you to write pentane, means you are aware that it should be having 5 carbon atoms. Okay, now how to find a number of hydrogen atoms? Let's see. 1, 2, 3, 4, 5. 5 carbon atoms are there. Now remaining valencies will be satisfied by hydrogen. So let's see how many hydrogen will be there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's C5H12, that is pentane. This is the easiest way of working it out. So if you are asked to write formula of pentane, you should remember that ane represents alkane, that is having all single bonds. Then second thing is that if all single bonds are there, pentane is there. So 5 carbon atoms have to be drawn and remaining valencies can be satisfied by hydrogen. One more trick is there. Okay, one more trick is there that in alkanes there is a general formula of CnH2n plus 2. This is the general formula for alkanes. So if N is 5, like in pentane, number of carbon atoms is 5. Then what will be the number of hydrogen atoms? 2 into 5, that is 10, plus 2, 12. Okay, so either by that way you can get the formula, or simply just write down the things and find the formula. That is the easiest way, and that you will land up with correct answer only. Okay, so that is how we can write about alkanes. Next is about alkenes. Alkenes means in the carbon series there is one place there is having a double bond. So if a double bond is there, that is known as alkenes. Now, to have a double bond, at least 2 carbon atoms should be there. So the first member of alkenes will be having a double bond, and that will be having at least 2 carbon atoms. Okay, what will be its name? What will be the remaining number of hydrogen atoms? 2 with this carbon, 2 with this carbon atom. Now, formula we can write as at C2H4. Okay, and its name will be ethene. For alkenes, ene is the suffix used. So since it is having 2 carbon atoms, so eth, and since it is a double bond present between the carbon atoms, so it's ene. So ethene. Ethene is a name for this particular carbon compound. Now, if it is having 3 carbon atoms, and if a double bond is present anywhere, then remaining valency is satisfied by hydrogen. Let's see. Remember that every carbon has valency of 4. Tetravalency is there. I know valency it's 4. So you have to satisfy the remaining valencies of carbon with hydrogen. What will be its formula? C3, and H if you count it will come to be 6. अगर हम जनरल फॉर्मूला की बात करें तो जनरल फॉर्मूला ऑफ एल्कीन्स इज CnH2n. You can check that. If a number of carbon atoms was 2, hydrogen will be 2 into 2, that is 4. Here C3, 3 2s are 6. So the alkenes have double the number of hydrogen atoms as compared to carbon atoms. So that is about alkenes. If 3 carbon atoms are there, then it is known as propene. If 4 carbon atoms, butene. 5, pentene. Likewise. Okay. The root word is the same as we have discussed in alkanes. Just the suffix has to be changed. So in alkanes it was ane. In alkenes, नाम में ही है वो ene. So the suffix is ene. Ethene, propene, butene. Now, one way the examiner can trick you is that he can ask you which is the third member of alkene series. Name the hydrocarbon that is the third member of alkene series. Which is the third member of alkene series? Is it propene? No, it's not. Third member of alkene series is 1, 2 and 3. Means it will be having how many carbon atoms? It will be having 4 carbon atoms in all. So since it is having 4 carbon atoms, it should be called as butene. है ना? We have to cover up the remaining valencies of the carbon with hydrogen, but its name will be butene because a total of 4 carbon atoms is there. So the first member is not having 1 carbon, it's having 2 carbon. The second member will be having 3, third member will be having 4 carbon atoms. So the third member of alkene series is butene. Remember that. That could be asked for any functional group. Then you don't need to get confused about it. It can come in MCQ questions also. Okay. So general formula is CnH2n. It's alkene having a double bond at any one place. Okay. In case of butene, you can place a double bond here, or if you don't want to place it here, you can place it here between the first and second carbon. If you don't want to place it either of the two places, you can place here also between the last two carbons. At any one place, you can place a double bond. So that is about alkene series. Such a series of compounds which have, if you just write the formula of that, C4H8. So in any of these series, the first series that we have seen was alkanes. In the second series, we are seeing alkenes. If you see the difference between the first hydrocarbon and the second hydrocarbon, that is a difference of CH2. It was having 3 carbon, it is having 2 carbon. The difference is 1 carbon, and number of hydrogen atoms, the difference is 2. So every series that has a difference of CH2, that is known as a homologous series. Okay, so we are going to read about many series, but we have studied about alkane series and alkene series. What's so special about the homologous series is that their chemical properties are same. If you take the chemical property of ethene and compare it with the chemical property of butene or hexene or octene, the chemical properties will be remaining the same. So that also can come as a 1 marks question. The property that will remain same in a homologous series, is it a physical property or a chemical property? That is chemical property, that is going to remain the same, but physical property is going to change. Physical properties means like boiling point, melting point, or molecular mass, that will be different. ठीक है, तो अगर हम कंपेयर करेंगे तो molecular mass, boiling point, melting point, they are going to increase when we go in the homologous series downwards. In any homologous series, whether it's alkane, alkene, alkynes, when we go downwards, obviously number of atoms are increasing. So its mass is going to increase. Just remember this. मास इंक्रीज हो रहा है और बाकी चीजें भी इंक्रीज हो रही है. क्या क्या इंक्रीज हो रही है? मेल्टिंग पॉइंट इज ऑल्सो इंक्रीजिंग, बॉइलिंग पॉइंट इज ऑल्सो इंक्रीजिंग, molecular mass is also increasing. Molecular mass तो सामने समझ में आ रहा है. Number of carbon atoms is increasing, number of hydrogen atoms is increasing, तो total mass भी increase हो जाएगा. Okay. One more question they can ask you, कि कोई एल्कीन सीरीज के या किसी भी सीरीज के कोई एक कंपाउंड का मास जो है that is 88. Suppose they ask you that its mass is 88, any of the series. What will be the mass of next member of the same series? तो नेक्स्ट मेंबर का मास पता करने के लिए हमें क्या पता करना पड़ेगा? जो मास ऑफ CH2. What is the mass of CH2? Because difference between any two members of any of the series is CH2 only. तो CH2 का मास देखते हैं कितना होता है. कार्बन का एक एटम का मास 12, हाइड्रोजन के दो एटम्स का मास 2e2, so that makes a total of 14. 88 plus 14, that will give you the mass of the next member of that particular series. Okay, so that could be the like most difficult question that they can ask you. Okay, not beyond that. So in this series, what we have remembered, what we have learned, it's very important. Alkanes are saturated hydrocarbons or having all single bonds only. Alkenes are unsaturated hydrocarbons having a double bond. At any one place, we can place a double bond. The name of the alkene series is for 2 carbon atoms, ethene, 3 propene, 4 butene, 5 pentene, and if it's 6, that is hexene. First member of alkene series is ethene, second member propene, third member butane. Okay, so if you're as a third member or you are as a fourth member, don't get confused. You can easily answer that question. Okay, one more question that was asked in one of the previous years was write the formula of next two compounds in the homologous series of next two compounds in the homologous series that comes after propene. So after propene, the two members that will come in the same homologous series will be butene and pentene. Okay, so after propene, which two members will be there? That will be butene and pentene. Okay, so that will be there for you. For these hydrocarbons, you could also be asked to write the electron dot structure. So for some of them, we are going to practice the electron dot structures also for alkanes, alkenes and alkynes. But first, let's see about alkynes also. Then we'll draw some electron dot structure for these. So alkynes. Alkynes are the hydrocarbons that have a triple bond between them. So minimum number of carbon atoms that are required to have a triple bond is 2. So the remaining valency is satisfied by hydrogen. So its formula will be C2H2. C2H2. Okay. If we see the next member, 3 carbon atoms are there. At any one place, we can place a triple bond. Remaining valency is satisfied by hydrogen. It's all the valencies are already satisfied. 3 and 1, 4. Here 3 are satisfied, 1 is remaining. So the formula is C3H4. Okay. So the first member of alkyne series was ethyne. That is ethyne. Second is prop for 3 carbon atoms. So it's propyne. Propyne. Next member will be butyne. 4 carbon atoms will be there and that will be having at any one place they will be having a triple bond. So that is known as butane. Okay. So next is the general formula of alkynes. So general formula of alkynes is CnH2n minus 2. Let's check it if it works. When 2 carbon atoms are there, then number of carbon atoms is 2. Then 2 2s are 4. 4 minus 2 is 2. So we have the formula of C2H2. Okay. Then if it is 3, then 2 3s are 6. 6 minus 2 is 4. That's how we got propyne. If someone asks you that write the formula of heptine. So one way to write the formula of heptine could be simply draw 7 carbon atoms. 1, 2, 3, 4, 5, 6, 7. 7 carbon atoms. At any one place, show a triple bond. YNE represents a triple bond. Okay. Draw a triple bond. At remaining places, just fulfill the valency of carbon by placing hydrogen. So it's already satisfied. This one is already satisfied. And then simply we can count the number of hydrogen atoms. This method will never fail. You need not remember anything, need not make any mistake in that. So let's now count 1 2 3 4 5 6 7 8 9 10 11 12. So it's C7H12, but we could have worked it out by using the formula also. N is 7, 2 7s are 14, 14 minus 2 is 12. So we have got that only. Okay. So for drawing the writing the formula or for writing the names of these compounds, we can just do that way also. Okay, using the general formula also we can find the name. If you are writing what is the name of this compound, okay, let me, please tell me the name of this compound in the comment section. I'm not going to answer you this question right now. I expect an answer from you all. So I'm writing the name, the formula of three carbon compounds. You have to write the names 1, 2 and 3. ठीक है, नंबर करके आंसर करना कमेंट सेक्शन में. तो फर्स्ट फॉर्मूला इज C5H8, second is C3H8, and third is C4H8. Okay, 1, 2 and 3. Write in the same sequence only. I would be glad to check your answers. Okay, so comment section में आपका आंसर लिखना. What will be the name of these carbon compounds? C5H8, C3H8 and C4H8. Okay, write down their names in the comment section. Now we have seen about alkane, alkene and alkynes homologous series. Now let's see about the electron dot structure. That is the last topic for this video. Drawing the electron dot structure for alkanes, alkenes and alkynes. Okay, so we'll just have a look about two examples for each. First we'll draw the electron dot structure for methane. Now when it comes to electron dot structure, they don't ask you very lengthy compounds like C5 carbon, 5 carbon compound, 6 carbon compound. They don't ask you that a big formula. Okay, they usually ask you about carbon compounds having 1, 2 or 3 carbon compounds. Okay, so methane, you all know that meth matlab one carbon atom and ane means all the bonds are single. So we have drawn one carbon and we are going to draw 4 hydrogen atoms, which was the first one. We already drawn that. Na? So this is the electron dot structure of methane. Why it's like that circle? Circles में क्यों show करा? Circles में क्यों show करा? Because that is showing the sharing of electrons. Okay. I want to know the answer of one more question. कौन से electron dot structure, the electron dot structure of which compounds are not shown using these circles? ऐसे कौन से इलेक्ट्रॉन डॉट स्ट्रक्चर्स हैं, किस टाइप के कंपाउंड्स के इलेक्ट्रॉन डॉट स्ट्रक्चर्स हैं जिनको ड्रॉ करने के लिए हम सर्कल्स यूज नहीं करते. ओके, टेल मी द आंसर इन द कमेंट सेक्शन. सो दिस इज द स्ट्रक्चर ऑफ मीथेन. नाउ लेट्स सी one more alkane, that is ethane. So ethane, you know, eth means 2 carbon atoms and ane means will be having all the single bonds only. So all the single bonds, ane, you know that CN, H2N plus 2. So H will be 2 2s are 4 plus 2 is 6. C2H6. Okay. Now we'll draw the electron dot structure for that. Whenever you have to draw the electron dot structure of any compound, na, first draw its structure. Then you will never make a mistake in drawing the electron dot structures. For here, 2 carbon atoms, all the bonds are single. So that will be shown by placing the hydrogen atoms. Okay. Now we know that what kind of bond exists. So we'll be drawing 2 carbon atoms. How many bonds are between the carbon atoms? Single bond. So we'll show with a single pair of electrons. Then every carbon attached to 3 hydrogen atoms. So 1 hydrogen atom having a single bond, another hydrogen atom, another having a single bond, and the third hydrogen atom again having a single bond. Okay. Similarly here also, one hydrogen atom having a single bond, another hydrogen atom having a single bond, and one more hydrogen atom having a single bond only. Okay. So this is the electron dot structure of ethene. sorry, ethane, sorry. It's ane because it's all single bond only. So it is ethane, and that is the electron dot structure. इलेक्ट्रॉन डॉट स्ट्रक्चर्स आने के चांसेस आपके एग्जाम में बहुत ज़्यादा हैं बिकॉज आई टोल्ड यू फॉर 2 marks questions you are going to have the application based questions, understanding based questions. So these are all understanding based questions, application based questions only. ठीक है, तो स्ट्रक्चरल फॉर्मूला पूछ सकते हैं. ये क्या है इसका फॉर्मूला? इथेन. This is a structural formula where you show the number of bonds, and this is the electron dot structure where you show the electrons also. Okay, so you could be asked to write the formula, you could be asked to write the structural formula or the electron dot structure. I hope my students are ready for all the three. Okay, now let's draw two alkenes and two alkynes also. So two alkenes that we are going to draw. First is ethene, C2H4. Okay, C2H4 वही पहले स्ट्रक्चरल फॉर्मूला लिख लेते हैं. 2 कार्बन है, 4 हाइड्रोजन आर अटैच्ड, 2 to this one, 2 to this one, and since it is ene, so it is a double bond. Okay, now very easy for us to draw the electron dot structure. One circle is there, second circle is there. Okay, between the 2 carbon atoms there exists a double bond. When a double bond is there, 2 pair of electrons have to be shown. One pair and the second pair. 2 pair of electrons are there. And then you have hydrogen atoms. 1, 2. Here also 2 hydrogen atoms are attached to it. 2 hydrogen atoms are attached to it. Okay, so this is the electron dot structure of ethene. This is the structural formula of ethene. This is the molecular formula of ethene, and the name is ethene. Okay, similarly for propene, I hope you can draw by yourself. 1 is enough. I planned for drawing for 2, but I think 1 is enough for you all. Just draw it by yourself, and I hope you will be able to draw it. If you have any doubt, if you're not able to draw it, just let me know in the comment section. I will help you out. Okay, in the next class. So next is alkynes. Let's draw the structure of propyne. Instead of ethyne, we'll draw for propyne. So propyne, you know that it will be 3 carbon atoms. One of the bond is a triple bond. Other valence is satisfied by hydrogen. So here it will be 3 hydrogen atoms attached to it. Here it will be all the valencies are already satisfied, so no more hydrogen will be attached. What will be the formula? C3H4. If we see the electron dot structure, then we have to draw 3 carbon atoms. So for drawing 3 carbon atoms, we draw 3 circles equal in size. Show a carbon atom in all the 3. Now, how many bonds are there between first and second carbon atom? 3 bonds are there. So we have to show 3 pairs of electrons. 1, 2 and 3. You can ask me, ma'am, earlier you were drawing dots, but now you are showing cross. Any of the 2 ways you can do that. Either show a cross or a dot. That means the same only. But better show a cross. That is clearly visible. Now here, it's a single bond. So that's a single pair of electron. Now first carbon is attached to 3 hydrogen atoms. Whenever you have to draw any electron dot structure, just mark my words that always first draw the structural formula. If you draw the structural formula, then you will be able to draw the electron dot structure correct only, always, for sure. And the first carbon is also having a single bond with 1 hydrogen atom. So this is the electron dot structure for propyne. Its name is propyne. Why propyne? Because 3 carbon atoms are there. So prop, and yne because it's a triple bond here. Okay, so that way we can draw the electron dot structures. So we have seen the homologous series of alkanes, alkenes, alkynes. We have also seen how to draw the electron dot structures of some molecules like hydrogen, oxygen, nitrogen, sulfur. We have seen the electron dot structures of alkanes, alkenes, alkynes, as well as the structural formula. Okay, revise this portion very well. This all with what we have studied together today are very important for your exams. Okay, So wish you all a very good luck. We'll see you again in the next video. Okay, that's all for today. Good day.